This is the solution to quiz 9. Okay, so solve the inequality using the sign chart method. Alright. So the first step in the sign chart method is to find the natural domain. Well, there's no radicals, so that's good. The only thing that could go wrong is we could divide by a 0, and the only time that can happen is at 2. So the natural domain is anything except 2. 2 now. We want to 0 and simplify the inequality. So one side is already 0, so that's nice. Then we want to simplify it. Well, does this factor? Can you think of two numbers whose product is negative 40 and whose sum is positive 3? Sure. So how about x plus 8? Multiplied by x minus 5, and then over x minus 2 greater or equal to 0. Okay, now we want to solve the corresponding equation. That is to say, we want to solve x plus 8 times x minus 5, divide by x minus 2, equal 0. Well, if we multiply both sides by that, that goes away. So x plus 8 times x minus 5 equals 0. So the solutions are negative 8 and 5. The next step is the actual sign chart. The method is named after this step. So specifically, we want to plot all the breaks in the domain and all the solutions to the equation. So there's 3 of those altogether. 1, 2, 3. Let's plot them in the right order. So negative 8, 2, and then 5. So negative 8, 2, and then 5. So we've cut the plane into those 4 regions. Now we need to sample in each one. How about negative 9 in this one, 1 in this one, 3 in that one, and 6 in that one. So what we're going to do is we're going to take those sample points and we're going to plug them in to this expression to check for sign. So if you plug in negative 9, you get negative, negative, negative. So negative times negative over negative. I think I'm almost out of green here. Let's fix that. So negative, negative, negative. Plugging in 1, you get positive, negative, negative. Positive, negative, negative. Plugging in 3, you get positive, negative, positive. And then plugging in 6, you get positive, positive, positive. Then in each region, the overall sign is negative, positive, negative, positive. Okay. Then, now that we've made the sign chart, we're in a position to make a conclusion. So we want all of the positive regions. So we want the positive regions. And so we've labeled all the regions as being positive or negative, and we want the positive ones because that is saying that we are looking for where that expression is greater or equal to 0. So that's why we want the positive ones. Here are the positive ones. And recall that that is a break in the domain. Otherwise, it says greater or equal, so we want the endpoints, but not that one. So the answer is -8, including -8, to 2, not including 2, and then union 5, including 5, to infinity. Okay. Okay, so f of 5, well, that's 3 times 5 plus 5. 3 times 5 is 15, plus another 5 is 20. For this one, g of 8a, well, that's 8a. We're going to square that. Add 1. That is 64a squared plus 1. F of x plus h, so that would be 3 x plus h plus 5. That would be 3x plus 3h plus 5. And then g of f of x, well, that would be f of x squared, because g squares its argument, and then adds 1. So that would be 3x plus 5 squared, add 1. So that would be 9x squared plus 3 times 5 is 15 times 2 is 30x plus 25 plus 1. So 9x squared plus 30x plus 26. And number 3. Okay, the difference quotient. So I'll do f of x plus h first by itself. So that's 2 x plus h, square it, 8 x plus h plus 9. So that's 2 x squared plus 2xh plus h squared. Then plus 8x plus 8h. Plus 9. So that's 2x squared plus 4xh plus 2h squared plus 8x plus 8h plus 9. So that's f of x plus h. So the difference quotient, f of x plus h minus f of x, this over h, is that. So 2x squared plus 4xh plus 2h squared plus 8x plus 8h plus 9, and then we're going to subtract that much. 2x squared plus 8x plus 9, and then all of this over h. So parenthesize that. Parenthesize that. Carry out that subtraction. The 2x's square, nothing cancels 4xh, nothing cancels 2h squared, the 8x's cancel, the 9's cancel. So what remains is 4xh plus 2h squared plus 8h, all of that over h. Now there's an h common in the numerator, so that would be 4x plus 2h plus 8h over h, and then we can cancel the h's. However, and that's what part of the instructions were about, is that this is the step from here to here. This is the fact, this is made possible by h being positive. In particular, all that we really need is that h isn't 0 because we're canceling h over h. And that's the answer.